All right, guys. So this lesson was the one that we looked at when we tried to figure out the halves of something, whether it was like closer to zero, the benchmark fractions. Um, and I noticed a lot of us had some questions about this, so I'm glad we're looking at this again. So just to recap, just to have a better understanding, and let's just do the warm up one more time. Uh, it says where is 1/2 on this number line? So I'm just gonna go ahead and say it's right here somewhere, and that is correct. It is right there. But we want to know like why? Why is this the half? Well, because it's in the middle. Yeah, but I want to know the fraction. Like, what's the math behind it? Okay, so I want you to think about this. If I know that this is the half, so I know that somewhere between 2/5 and not two, 3/5, like somewhere in here, there has to be my half. Okay, now 2/5 is less than 1/2, right? So if my half is here, if I go that way, 2/5 is less. If I go to the right, you would think it is greater, right? So 3/5 is greater than 1/2. Okay, but it's still close to 1/2. So both of these fractions, 2/5 and 3/5, are close to the half. Okay, so now let's try to figure out where half is. So what I like to do is maybe break it down into, see how there's a 5 in the denominator position. Well, what I can do is try to see if I can get a number that's a composite number that maybe I can find a halfway point. So I know if I multiply 5 times 2, that's going to give me 10. And half of 10 is 5, right? So I need 5/10. I need 5/10. Well, how can I break this up? Well, one way to do this is to make kind of how we were doing in our the other day, breaking these into smaller pieces. Remember, this is like if we were folding it, okay? So now we don't have, well, we still have fifths, but we have even smaller pieces, and these would be called 1/10. And again, this is 1/5, but it's also 2/10. So both of these numbers are the same, 1/5 and 2/5. 3/5, and then this is or I'm sorry, not fifths. What am I thinking? Here we go. Tenths. I'm so sorry. Here we go. And then 4/10 right here. I'm looking at the fifths and I'm thinking about that. So notice how all of these are tenths. Even the ones that were already fifths also have an equivalent fraction, okay? And then we'll have 5/10 right here. We'll have 6/10 right here. 7/10 right here. 8/10 right here. 9/10 right here. And then again, this would be your 10/10, which is a 1. Now, this is a lot easier to find the halfway point because I know that 5/10, or that half of 10 is 5. So this would also be an equivalent fraction, 1/2. So my halfway point would be right there, okay? Now, we'll look at more examples, but this is basically what we're doing. We're trying to identify whether it's closer to 0, to the halfway point, or to 1. Okay, so anything close to this range, let me draw that circle again. Anything close to here, that's the halfway point. Anything closer to this end would be your 0, and anything closer to this side would be your 1. All right, let's go. Keep on going. All right, guys, so let's go ahead and look at this example. We're on the last page of the notes, or no, second to last, I think. So let's go ahead and look at this. Remember that we were trying to get something that's close, but not, or close. That has to be close, but it has to be less than 1/2. Okay, so if you remember our example that we had, 3/5, and then we had 4/5, or sorry, 4/5, 5/5, and then 2/5, and then 1/5. The example at the beginning, we were trying to see where is our halfway point, right? And 0 over here. So our halfway point had to be somewhere here. This is our half, like right here somewhere. But it has to be less. So that means that all these other numbers I'm not going to use. I need to look at all the number that are over here on this side. Okay? And let me go ahead and see if I can explain that a little bit better. Where is it says it cannot, but it has to be less than. So I'm going to go ahead and write that here. Less than 1/2. If I know my halfway point is here, it has to be these numbers. It cannot be any number after the halfway point. So if this is the halfway point right here, it cannot go that way. No, it cannot go that way. Okay, and I know it's going to be a little bit weird and complicated. In my mind, I almost always think about a number line and try to find the halfway point. So it's going to be a little bit difficult if if you try to think of your multiples. Okay, so if, I think what numbers give me half of this number, right? And let me show you an example. Let me show you my thinking for this. Alrighty, guys, so let's go ahead and look at this example right here. Let's look at B. Oh, sorry. Let's look at B. Okay, I know this may have given some of you guys a little bit of trouble. And if not, I'm glad, okay? Because this can get a little bit complicated. But let's take it slow. So first of all, it says it wants to be really close to the halfway point. Really close. Okay, so we know we can't get to, well, we could if we made smaller pieces, but that's going to get really weird, okay? And really, it's going to take a lot of time, especially if we're drawing out a number line. So 27, what is half of 27, or about half of 27? Now, let's go ahead and see. One way that I wanted us to really think about this, well, let me see. I'm going to divide 27, and I know I'm going to get a remainder, but I just want to divide it to see what I get. So that's going to be 1 here. Gives me 0. And then how many times can 2 go into 7? That's going to be 3 times. Because then I get a 1. So about 13. Okay. So anything around 13 might be halfway than 27. Okay. We want to be less than that. So if it has to be less than that, my answer around right here somewhere, it's going to be 12 over 27. Okay, because I know that about the halfway point is 13, and I need less than that, so I'm just going to I'm going to stick to 12 over 27. Again, we're just estimating right now. This does not have to be perfect. If not, we would have to try to figure out a different denominator here. But here we're just trying to figure out about what's less than that, like closest to the halfway point, and then a little bit less. Some examples may ask you for a little bit greater than. So if it was asking us for greater, then we would have done 14. But in this case, they're asking us for less, so we're doing 12. Okay, now let's look at another example where we have a missing denominator. All right, guys, so let's look at the next example. We're going to look at D. Oh, sorry. Keep on forgetting to change my pencil. Here we go. We're going to be at D. So D is asking us for to add the denominator for a fraction that is 7, and then there's a space right there. Okay, now, this is what I want us to think about, okay? Remember that the numerator is the number of pieces that's shaded, or maybe, yeah, we'll just say shaded. Okay, so like, for example, if I have a box right here, and then I just do like that, I have one of the 3 shaded, right? Okay, and then the bottom number is just the number of equal boxes. So 3 boxes. They're all the same length. Okay, that is still something that can get a little complicated. But just remember that the denominator tells us how many equal boxes or circles you have, equal of something. So just make sure you do not forget that. The bottom number, the denominator, is the number of equal pieces. Let me say that one more time. Equal pieces that you have. So if you have 1/2, the bottom number is a 2. You have 2 equal pieces. Okay. Now, we're trying to get to half of... we're trying to get closest to half, but less. Okay, so we've been talking about that already. I know that if I put a 14 right here, that's actually the halfway point, right? I know that 7 over 14 is actually 1/2. Okay, so I'm close. But now I need something that's less than this. Okay, I gotta go down. Now, I want you to think about this because this can get a little complicated. Anytime you make the bottom number smaller, that means that the equal pieces, there's less equal pieces. For example, let's say I write 7 over, let's say I take this number down. Let's do 7/8. Well, 7/8, I have 8 equal pieces, and now I have 7 of them. That sounds like this is closer to 1, right? Oh, okay. Well, let's see. Let's try to go in the opposite. Let's try to move the 14 way up. Let's do... I'm going to go a little extreme here, and I'm going to do 7 over 70. Ooh, there's 70 pieces. I only have 7 of them? Almost sounds like it's closer to 0. Okay? So you have to look at the relationship between both of these. Okay? Both of the numerator and the denominator. Well, I'm trying to get the closest I can to 1/2, but it has to be less. So if I'm trying to do that, I'm going to go ahead and write my 7. And I can't go down. My numerator can't go down because then I'm going to get an 8, or I'm going closer to an 8. So even if I wrote 13 or 13, 12, any of those numbers, my fraction is actually, my pieces are actually getting bigger. Okay, I have more of them, which is, like I said, closer to 1. Well, what if I do 15? Well, that's perfect because I know that 7 over 14 is half. But if I have 15 pieces and I only have 7 of them, that's really close to the halfway point, but it's less. Okay, I'm going to go ahead and let you do the other examples, and then we will come back, all right, and check. Alrighty, guys, so these are some of our answers. The top one, A, is pretty easy because I know what's half of 12? It's 6, but I need less than that. Okay, less would be a 5, so that would be a 5 right there. Okay. 9 over 19. Okay, why did I pick 19? Well, because I know that 9 over 18 is 1/2. And if I go down to 17, 16, I have more of the numerator, so I have to go up. Okay, so the numbers go up, so the value that you have, or the numerator, is less. I know that sounds weird, and I'm sorry for that, but if this number goes up, so if this one is going up, 19 is going up, that means that there are less of the 9 pieces. So imagine if I had 9 over 10. That means my 19 was going down. Look at this, 9 over 19. 9 is really close to, if I had a number line, 10 over 10 would be right here. And then 9 over 10 would be right here. So really close. So we want to make sure that we're getting less than 1/2. Now, that's not going to be always the case. Sometimes they may ask you for greater than, but this is basically what you have to do. You have to make the numerator bigger so it's less than 1/2. If you want to make it smaller, then that means it's getting closer to 1. Okay? These are our answers. Go ahead and check your answers. And that'll be it. I'll see you in the next one.